Hey, welcome to the Explainer. Ever stop and wonder how your computer actually talks to another one? Or how it connects to the entire internet? It all comes down to a few really fundamental ideas. Today, we're going to break down the essential building blocks of how all this digital communication really works.
Okay, let's just dive right in. Here's our game plan. We're going to start with the absolute basic rules of conversation, then we'll build out a private network, look at the smart way to connect devices, and finally, figure out how we connect our own little digital worlds to everything else out there.
So first things first, before we can even think about building a network, we have to get a handle on the basics, like how do any two devices even exchange information? These are called transmission modes, and they're pretty much the ground rules for any digital conversation.
All right, first up we have something called Simplex Mode. The easiest way to think about this is as a one-way street. In Simplex Mode, a device can either send information or it can receive information. It can never ever do both. The data just flows in one direction, period.
And you can see it right here. It's just a straight shot from the sender to the receiver. It is a simple, direct, one-way street for data, and there's just no path for a reply to come back. The best real-world example? Your car radio. I mean, the radio station sends out a signal, and your car picks it up. You can listen all you want, but you can't talk back to the DJ through your radio, right? Same thing goes for your keyboard and your monitor. The keyboard only sends info in, and the monitor only shows info out.
Okay, so what's the next step up? That would be Half-Duplex Mode. This is a big improvement, because now our devices can actually have a conversation. They can both send and receive data, but, and this is the big catch, they can't do it at the same time. One has to finish its turn before the other one can start. So the key thing to see here is that, yeah, the data can go both ways, but it can't happen at the same time. The line is shared, so traffic can only move one way at any given moment.
You know, if you've ever used a walkie-talkie, you've actually used half-duplex. You push the button, you talk, and then you say over, which is your signal that it's the other person's turn. That little bit of delay, where one person always has to wait for the other to finish, that's the main disadvantage of this mode.
And that brings us to the big one, the one we all know and love, Full-Duplex Mode. This is really the goal for most communication. Here, two devices can send and receive information at the exact same time. There's no waiting, no taking turns. It's a real, simultaneous two-way conversation.
Now, the secret sauce here is that it basically uses two separate channels. You have one for sending and one for receiving. This creates a dedicated lane for data in each direction, just like a highway, which is what allows for that amazing simultaneous communication. The absolute perfect analogy is just a normal phone call. You and your friend can both talk at the same time, you can listen at the same time, you can even interrupt each other. That natural back and forth flow is exactly why full duplex is the standard for almost all the modern communication we use every single day.
So here's a great little cheat sheet that pulls it all together. You can see everything at a glance, from the direction of the data flow all the way to performance and those real-world examples. It's a perfect little summary of the core ideas we just covered. All right, so now that we've got the rules of the road down, how does this all work when we start connecting lots of devices together? Let's build on those basics and talk about creating our own private network.
This brings us to two really important concepts, the intranet and the extranet. Just think of an intranet as a company's own private internal internet. It's for employees only. An extranet is pretty similar, but it's like opening a special secure door for a few specific outsiders, like your suppliers or your customers, so they can get access to certain parts of your network. And why does this matter? Well, for an organization, having an intranet is a total game changer. It creates this secure digital hub where employees can communicate super easily, they can share information instantly, and they can collaborate securely. And of course, it saves a ton of money by cutting down on paper.
Okay, so we've got our private network, but how do we physically plug all the computers and printers and everything together so they can talk? This is where devices like hubs and switches come into play. And believe me, there is a world of difference between them.
So there are really two ways to connect devices. There's the old way, and then there's the modern way. The old, pretty inefficient method used a device called a hub. But today, pretty much every network uses a much more intelligent solution called a switch.
A hub is, well, it's really simple, but it's also really inefficient. Imagine a mailroom clerk who, instead of delivering a letter to one person, just stands in the middle of the office and shouts the contents of the letter for everyone to hear. That's a hub. It just blasts every single piece of data to every single device on the network. You can imagine how that creates a ton of unnecessary traffic and just slows everything down.
A switch, on the other hand, is so much smarter. It's like that efficient postal worker.
When a message comes in, the switch looks at the specific destination address and delivers that message only to the one device it's intended for. It doesn't shout it to everyone. This makes the whole network way faster, more efficient, and a lot more secure.
All right, we've built our local network, we've connected our devices intelligently with a switch, but right now it's basically an island. So how do we connect our private little world to other networks and to the big one, the internet? For this, we're going to need a few specialized devices. First up is the modem, which is just short for modulator-demodulator, and really its whole job is to be a translator. See, your computer speaks a digital language, but the signal coming into your house from the phone line or cable company is often an analog one. The modem's job is to translate between those two languages, back and forth, so they can understand each other. Now, what if you have two separate parts of a network, say one on the first floor of an office and another on the second floor, and you want them to act like one big network? That's what a bridge is for. It's a pretty simple device that just connects two similar local networks, or LANs, and basically combines them into one single, larger network.
But the real powerhouse connector is the gateway. A bridge connects two similar networks. A gateway, though, connects two completely different networks that use totally different rules or languages. It acts as a universal translator and is the main entry and exit point, allowing your home network, for example, to connect to the entire global internet.
So from a simple one-way flow of data to these complex gateways that connect different worlds, we've seen the fundamental components that built our digital lives. These really are the building blocks of the internet as we know it. And it kind of makes you wonder, as our world gets even more connected, what new kinds of building blocks are we going to need to invent next?